Okay, so we have a little bit left to do in chapter 6. So I want to go ahead and finish that. Also, we'll practice a bit with the calculator. And then there's one problem I want to do in the review that kind of throws people off of it. But I do want to give you a good, at least like 45 minutes or so to work on the reviewing class in case you have questions and get ready for the test on Tuesday. Okay? Here, we're talking about probabilities again. I don't want to spend too much time on this, but it is kind of good to practice. Let's say you're about to have a baby. What's the chance that your baby is going to be a girl? 50-50, right? So the chance is 1/2, 50-50, 0.5. That's the probability of having a girl. This question isn't really asking that. It's kind of that. It's asking, what's the chance that the first one's a girl? The second one's also a girl. The third one's also a girl. The fourth one's also a girl. The fifth one's also a girl. Do you think the chance stays the same, that they're all going to be girls, or does the chance go up or go down? Down. Kind of goes down, right? Because eventually what needs to pop out? A boy, probability-wise. Okay, whatever one you want, it's up to you. Okay? So that's what this is talking about. That probability is 1/2 raised to the x. And the x is number of girls in a row. Okay? So what we have is this little table. And we're going to fill it in, but we're also going to use the calculator a little bit too. So what's the chance that the first child is a girl? Well, that's 1/2 raised to the 1. Okay, if we go to the calculator, let's practice that a bit. Let's put parenthesis 1 division 2 parenthesis raised. The raised is above the division. The raised is above the division. Raised to the 1, you get 0.5. Okay, so the chance that the first child is a girl is 0.5, 50%, half. What's the chance that the second one is also a girl? Well, a little calculator trick. If you don't want to type that in again, I can put second enter, second enter, second enter. So if you don't, take your calculator, put it in your hand, push parenthesis 1 division 2 raised to the 1. Make sure you get that 0.5. Raised is above the division. Make sure you get 0.5. Now, if you don't want to type it in again, if you hit second enter, it repeats it for you. You go back and change the 1 to a 2. So the chance that the second one is a girl goes down to 0.25. Okay, well that's making sense. Well, let's keep going with that. Okay, what's the chance that the first, second, and third are all going to be girls? Enter, second, enter, second, enter. Change the 2 to a 3. You get 0.125, 12.5% chance that all 3 are going to be girls. Okay? What's stories that you've heard where it's all girls or all boys? What's the most? 7? So all 7 boys, and then the 8th one was finally a girl. Wow, we'll find out the chance of that happening. 7 boys in a row. I feel bad for them. Okay? Yeah. I would have said the same thing if it was a girl. So now you'll notice this is a bit tedious, right? Second, even doing second enter is tedious. So I'm going to show you a fast way to do it. But before I show you the fast way to do it, let's go ahead and fill in the rest of these. 4 girls in a row, 5 girls in a row, 6 girls in a row, and then we'll go to yours. What's the chance of having 7 girls in a row? 8, 9, and then we'll just stop at 10. Now you're having a soccer team at this point. Okay? Now, I could sit here and type each one in, but I kind of showed you a fast way to do it. So here's the fast way to do it. Everyone go to y equals. Y equals. This is the place where we graphed. But we're going to go to y equals, get rid of anything you have in there, and let's put the original function. The original function is parenthesis, 1 division 2 close parenthesis, 1/2. But we're not going to raise it to a number. We're going to raise to an x. Raise to the x. Raise to the x. Because x could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So first let's make sure that in y1 we all have parenthesis 1 division 2, close parenthesis, raised to the x. My calculator just raises it. Yours may have the little raise symbol, little caret, x. Not a number, x. We good? Just to make sure our table's set up, we already did this in class, but just to double check, everybody hit second window, second window, second window, second window, second window, second window. Second.
No, figure it out now. Raise to the power. Okay. Yes, this one.
Good. It should say ask auto, ask auto. If yours still has auto highlighted, you didn't change it last time. So make sure it says ask auto. Make sure that the independent, push enter on ask. Dependent should be on. Does everyone have ask highlighted, auto highlighted? I don't care what the numbers are up top. Just make sure it's ask auto. Does everyone have that? Good. Now we're going to go to the table feature by hitting second graph. Second graph. Second graph. If you got stuff in there, just hit delete. And here's what's cool about your table. Your table, you tell it x, it goes to y1, plugs in for x, and spits out y. We did this for the height example, but we'll do it again for practice. So when I type in 1, it takes 1, plugs it into the function. There's your 0.5. 2, 3, 4, 5, 6, 7. You'll notice there's 7 spaces. Let's fill in the first 7, then we'll go back and do the other ones. But this is a fast way to plug in for x. So when you're plugged in for x on the test or on your homework or for your creator problem, that's what you do. Okay? But notice it does end at 7. So all you got to do is go up to the top and type on top of it. 8, 9, 10. Okay, make sure you're getting the same answers as I'm getting. And you'll notice that 10 is weird. You'll notice that 10 is weird. Okay, is everybody getting the same numbers? What does 10 mean? 9.8 e to the negative 4. What do you think that e to the negative 4 means? It's scientific notation. It's like that times 10 raised to the negative 4. Basically, it means start at the decimal, and negative means move to the left. How many? 4. 4. 1, 2, 3, 4. So if I do that, will be 4 zeros? Got 3 zeros. 1, 2, 3, 9 eights. Okay? So I just wanted to show you again the table feature. It is a fast way to plug in x. Now, let's go back to what she said. What's the chance of having 7 girls or boys in a row, either one? What's the percent chance if I change that to a percent? 0.78%. 0.78%. The chance of that happening is less than 1%. The chance of having 7 boys or 7 girls in a row is less than 1% chance. That person should play the lottery. They kind of did, right? Now, those are my answers. But the last thing we did in class was talking about a probability distribution graph. And so I'm going to draw what I see here. I'm going to put the number of children here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the probability is going to go on the left side on our y-axis. And the highest probability is 0.5. So I'm going to do 0, 0.1, 0.2, 0.3, 0.4, 0.5. I'm going to go up to 0.6. And the chance of having the first one, let's say be a girl, is 0.5. The chance that the first and second are girls is 0.25. All 3, 0.12, 0.6, 0.3, 0.1, 0.5%, and then it just gets really, really small. So you can see that chance just drop. And that's just a nice example of the probability distribution graph. Questions there? So again, this is kind of a bonus extra example. I did want to finish it off. Now, before I let you loose to work on your review, notice I'm not covering 6.2. Why am I not covering 6.2?
Same as 3.2.
It's just, is it 3.2? I forgot the section. It's the same as chapter 3 z-scores, right? And so, yes, you have more examples to practice, but instead of me going over them and you copying them, I want you to work on it. So I gave you a whole other set of problems talking about the distribution of time for football games is normal, where the average football game is 180 minutes, 3 hours, with a standard deviation of 20 minutes. And then I gave you a less than, I gave you a more than, I gave you an in between, percent below, percent above. Okay, so you can work on that today if that's the area you're struggling with. You can practice z-scores. Yes, it's on the test. It's part of chapter 6. Are we okay? Then you have a nice little test review to work on. Please double, triple check, go through the test review. Yes, you have the answers, but don't look at the answers till you do it yourself. Okay? Sometimes we look at the answers too soon, and then we feel like we already know it, but all we're doing is copying the answers. Everything's in black. Are we okay? And again, test review is a sample of the test. It's not exactly the test. It's just an idea. But there is a question I do want to go over. And if you've been working on the review, which I hope you have, it's question 5. Okay? So I want to cover question 5. Question 5 says, researchers studying acid rain measured the acidity of precipitation in the Colorado wilderness for 150 consecutive weeks. Acidity is measured by pH. Lower pH shows higher acidity. The acid rain researchers observed a linear pattern over time, and they gave us the least squares regression. So the reason why this is weird is every problem we did 4 problems in chapter 4, but every time we did, I gave you the data, you took the data, put it in the calculator, and then it gave you this, right? Different order, but it gave you this. This is kind of the order my stat lab likes, where they do the y-intercept in front, slope in the back, but it's the same thing. So we don't have data this time, but you still should be able to tell me what is the input, the explanatory, and what is the output, the y, the response. So don't say it out loud. Take a minute, write down what is your x, what is your y. That is the most important thing. If you don't know that, bless you, we're not able to answer anything. And that's our mistake, is that we're running the problem without clearly identifying what's our x, what's our y. If we don't know which is which, there's really no way to solve it. Okay, so being clear, which is our x? Weeks. You tell me how many weeks have gone by. What's my output? pH. This is huge, 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 huge. A couple of reasons why. Number one, it kind of makes sense. You have to tell me how many weeks have gone by before I can tell you what the pH is. Does that make sense? So that kind of makes sense. And the other big clue is input, x. This would be our x next to the slope, next to the y-intercept. The output is what it equals, pH. So there's a bunch of clues in here. Does that make sense? Remember y equals mx plus b? There's your y, there's your x. Just the formula alone tells you which is which. Are we okay? And it kind of makes sense that you tell me how many weeks, I need to know that first. That explains what the pH is. Are we okay? Now, I asked you to graph it. We're not graphing data. What's the only thing we're graphing? Which is a line. All we're graphing is a line. But in order to graph the line, you got to figure out the window. And then part of you is like, wait a minute, I can't figure out the window because normally we look at the data. In order, I need the data. So how can I figure out the window? You do have enough clues. Okay? So first of all, what goes on our x-axis? Weeks. Y-axis? pH. Now, remember, this one's talking about measuring the precipitation in the Colorado wilderness for 150 weeks, trying to figure out what the pH is. That's what the problem's about. What clue do we have about the weeks? It's 150 weeks. So my x-axis will start at 0 and go until 150. And what should we count by?
Maybe 25.
Like 25. Good. 0, 25, 50, 75, 100, 125, 150. Are we okay? Now, what clue do they give us for the pH? This is where it gets a little tricky. There is a clue. It's in there. Where's the clue for the pH? The what? Good. So he's pointing out a few things. He said negative. He said starting point. Where's he getting all that from? The equation. The equation is pH equals 5.43 minus 0.0053 weeks. All right. So what's the pH starting at? 0.3. That's your y-intercept. Is it going up or going down? How do you know it's going down? Slope is negative. See how you have to understand what everything means? So a good starting point is, well, if I need to see 5.43, let's go up to at least 6. And then it's going to go down, so maybe let's go down to 0. So my y-axis would go from 0 to 6, counting by ones. 0 to 6, counting by ones. But again, you're never going to get that window unless you understand y-intercept, y-intercept, and slope. Are we okay? So that was a little tricky because it didn't give you the data, and we're so used to having the data, but it is there. It is there. There are clues. So to check if we're correct, we go to our calculator. We press y equals. Get rid of anything else you got in there. Get rid of y1, y2, y3, and make sure that your plots are off. So if you have a plot that's highlighted, like if plot 1 is highlighted all the way on top, go up to plot 1, push enter, make sure all of your plots are off. We want the plots on when we want to see data, but do I have the data? No, so we want all the plots off. So in y1, we put the equation, 5.43, subtraction 0.0053, and instead of weeks, what am I going to put? X. So in y1, we have 5.43 minus 0.0053x. Okay? Now, if I hit graph, you're not going to see anything. Why? You have to set up your window. So you push the window. You push the window button on the top row, second button, window. What is your x minimum? 0. What is your x maximum? 150. What is your x scale? 25. What's the y minimum? 0. What's the y maximum? 6. And what's the y scale? 1. Again, you don't need to write that down. I got it from the picture. 0 to 150, counting by 50s. 0 to 6, counting by 1. Make sure you're not copying. Make sure you're understanding where it comes from. And if you did it correctly, when you push graph, what should you see? A line. Where does the line start? 5.43. Downward. All about the understanding. That's going to be the difference between people that get the A and people that don't do so well. They're trying to push buttons that they don't understand. Are we okay? So I wanted to cover this one because it was a little weird because we're used to having the data. But if you understand, it's all you needed. Are we good? Yeah. Now, I am going to fly through this problem because I think the most missed questions on the test come from this problem, this type of problem, let's say. Okay, so I will fly through it, but again, take your time, do it on your own, all that wonderful stuff. Is the association positive or negative? Negative. Why is it negative? Slope is negative, the line is going downward, left to right, bunch of reasons. But here's the most important part. What does negative mean in the context of this problem? As what? As weeks increase, the pH decreases. We okay? Now, looking at this problem, what's the slope? Good, I like how she said that. Negative 0.0053. If you forget the negative, it won't work. And I'll even give you a clue. It's negative 0.0053 over 1. What's the y-intercept? 5.43. The most missed question on the test. Explain the slope, explain the y-intercept. We did it 4 times in this class. Not counting college algebra, not counting homework, not counting all that stuff. So let's see right now if you would get it right. So don't say it out loud. Explain the slope in a sentence. Explain the y-intercept in a sentence. If you can't write it, you don't know it, right? So you got to learn it. And we got a ton of examples. This is really to prove do we know it or not. Okay, so here's the deal. Do we know it or do we not know it? If we don't know it, just study it. This is something we've been going over and over again. How do you explain slope? Output over input. What's the output? What's the output in this example? pH. What's the input? Weeks. Once you write down which is which, it basically writes itself. You just got to know what's what. You need to know X is weeks, Y is pH, slope is output over input. That's, we've gone over and over in college algebra and over because everything has a meaning. Everything's important. So every what? 1 week, the pH decreases. Now, am I going to say decreases negative or just decreases? Just decreases, 0.0053. If you put decreases negative, yeah, I'll take a point off because it's wrong. Okay, you don't want to do a double negative. How do you explain a y-intercept? When x is 0. What's x? Weeks. So at week 0, the pH is 5.43. So bottom line, when we started the study of the wilderness, measuring the acid rain, it started at 5.43, and what happened to the pH? Every week it went down 0.0053. Everything has a mean. Everything has a mean. Are we okay? Now, I'm going to go through these quickly. But for D, when I give you weeks, does that go in for X or does that go in for Y? X. So this would be pH equals 5.43 minus 0.0053 times 1. pH equals 5.43 minus 0.0053 times 150. Now, I personally, and I recommend to you on the test, show work, right? Show your work, you get partial credit if it's wrong, you are clear where the 1 goes, where the 150 goes, what you're looking for. But I'm going to do it in the calculator. Remember, I have my equation in Y1. So when I go to the table, I plug in 1, it spits out the pH. I plug in 150, it spits out the pH. So you use technology, right? If it helps you a little bit, if you learn it, use it. And so, also know how to write this in a complete sentence. At week one, the predicted pH is 5.42. At week 150, the predicted pH is 4.64. Okay? In the second example, it says, now I'm giving you pH, find the week that pH happens. And remember, it's always predicted, expected, all that kind of stuff. Where's the pH going to go in for? Y. So if I have a pH of 5, it's 5 equals 5.43 minus 0.0053x. For 4.75, it's 4.75 equals 5.43 minus 0.0053x. Okay? I'm going to let you do the work, do the algebra and all that stuff, but I will give you the answer just to make sure it matches. When does the pH reach 5? That would be week 81.13. So the pH will reach 5 at estimated approximately week 81.13. The other one of 4.75, the answer will be about 128.3, week 128.3. Again, predicted estimate. Okay? Now the review is important. There's going to be a bunch of weird questions. You got to do it. You got to practice it. We did 4 examples in class, the long ones. There's a 5th one in here. So the rest of the time we'll be working on the review.